Hi, welcome to this presentation. Akshat is a hardcore Linux and Debian user, and his experience with container technologies like Docker, Podman, Kubernetes, etc. Today he is going to tell us about his experience with Podman, and he's going to compare it with Docker and show us why he thinks that Podman is better. Please give a round of applause to Akshat.
Thank you. Today, I am going to demonstrate what are my experience in the last couple of months when I have started using Podman. So it started when I have used OpenShift. During that, I came to know with Podman. I was fascinated with how it is deeply integrated with Linux and how it is implemented with security kept in the mind. So up to now, I was using Docker, and now I have completely shifted to Podman. So this is a quick overview what I will be covering. So basically, I will hopefully most of us knows containers and how images and layers and file system works. So I will go quickly over that and then go through the container, Podman, and the differences with the Docker. So starting with containers, like as in the open source community, we know containers are basically Linux. It existed from more than the decades. It was already there. We were not using that much, and yes, thanks to Docker, it has revolutionized a lot. So these are basically the Linux mechanism to run Linux process with some degree of isolation and separation, so that application are not interfered with each other. They make use of the Linux primitives. Yes, they are the combination of few different Linux primitives like control groups, namespaces, union file system, seccomp, and SE Linux. So basically, these are the core things which makes these containers. So what we use now. So if we go in detail about the control groups, which is there as a Linux primitive types, so it organizes all the process in the Linux in a form of a hierarchy. Each and every process in the Linux is tracked. So these processes are tracked, grouped, and organized, and each process is associated with the resource. If we see the C groups, which is mounted at sysfs C group, which we can interact with a virtual file system. So we will find there is a file called task, where we have a list of process. So it's not like it's completely one process is associated with one C group. It can be exist in multiple C groups. So basically, C group is like an abstract framework, and we interact it through a subsystem. So there are different subsystems like memory, CPU time, block I/O, network priority, and devices. So through which we are able to interact with it, and these are the independent, like I mentioned, like one process is not tied with one particular C groups. They are arranged in the form of hierarchy, and we can also move one process to another C groups. So these basically prevent to exhaust resources of other containers. So it should not exhaust all. So other one important is namespaces. So basically there are two types of spaces. Like one is kernel space and other is the user space. And these namespaces are majorly concerned with the visibility of the resource and access control. Like one library is not access to the other libraries running in two different namespaces. Namespaces helps in process thinking that it is running there, having own copy of the resources, and also we can have inter namespaces mapping of the resource. Like one namespace can be also mapped to the other, and other one can also be mapped to the first one. We can see with ls/ns all the namespaces which are there in our Linux file system, and this can be manipulated, persisted, and entered through syscalls. Unlike in C groups, we can do it through a virtual file system, but here we do it with syscalls. So container images, most of us knows are a set of files and directories that are running inside a container, and they describe the installed state of the system. And after that, we have the concept of layer, which is having a mechanism of composing files and directories together to give us a unified view. Like if we have an application that requires a Debian to be installed, so we don't need to write the Debian image from the scratch. So it will, we use the inheritance and take the Debian image and implement our own application. So it provides all the CRUD operation. Basically, this is a union file system, and in Linux, we are provided with the overlay file system with default, which provides the merged view of the directory. And this Docker uses, by default, the overlay file system. And here, like there are multiple layers are there, so it joins like upper and lower directory to form a union file system. Like suppose we want to edit a file, then if it is present in a lower directory, then it is copied to the upper one, and we do the editing. While in case of writing, it should be able to directly write at the top level. And if you want to delete, then it just simply hides it with the use of whiteouts. So as we see in the container ecosystem, Docker is the well-known space. It's become a synonymous to what we use containers. So right now, everyone calls a Docker file, Docker images, Docker registries, Docker containers. So it's not the case. Like over the time, many companies came together, and they have built some standards. And that standards are maintains a specification for how the container should run, how it should manage, container image should be. This is called Open Container Initiative, and the idea behind it, like we should have one specification and we can have multiple implementation on it, so that we are not tied to one particular idea and someone centrally taking the decisions and giving the specification, and we have to follow. Container engine basically is a human interface for running a container. Like if you want to say, please pull me one Debian image from the q.io, which is a registry. So it basically pulls to the disk and stores in the storage, configures the runc, which is a container runtime, and launches the container. So example of it are OCI and container runtime interface. As I have told, they are basically the tools that configures the Linux primitive types. So we have two types of container runtime, like high level and low level. High level is like containerd, which is by Docker, and cryo is by kubernetes, and the other that is used for cryo is used for orchestration, like the kubernetes does, while the low level, which actually performs the job and creates the container and runs the container, are the OCI component runtime, like runc, crun, kata, gvisor. So basically runc is the reference implementation of OCI. This is it has implemented all the specification which has listed by the OCI, and it provides all the feature as expected by the OCI. So it provides all the low level functionality for the container, like for creating and running the container using the Linux primitive we have seen using C groups and namespaces. It's written in Go, and the other one are like implemented in C is crun, kata runtime, gvisor. So now we came to 6 building, these are the 6 building blocks for running a container. So we should be having a OCI compliant image that works with any of the implementation, no matter if it's a Docker, Podman, or whatever. Mechanism to pull a registry from the container registry, not specific to a particular provider. So over the, initially it started with the project like in Docker. Historically, we are pulling the whole image, and until and unless we have pulled down to our host machine, we don't know what it was. So they have requested, but the pull request was rejected because it can interfere with the functionality. So Scopio project has came into existence where we have these facilities, and over the time it has grown. Like we can move one registry, copy one registry to the other without pulling to the host machine. And other thing we should be having is storage for exploding our image, and a standard OCI compliant runtime, and a process for monitoring the container, like the Podman or Docker don't have to continuously monitor that process. For that command do the job, it captures the last image, last time process, and stores it. And then it also exists. And the networking. So this container networking interface is a networking protocol that was introduced by Core OS. So these are basically the basic building blocks for running a container. So now we came to Podman. Podman is like, there are no big fat daemons. Like in Docker, we have a client server model. So that is continuously running a daemon on our machine, and that daemon is having running on a socket and having a privileged access. So if we are running a process, so whatever the process is there, it's a process of the Docker, not the process we have executed. So it is the problem with the Docker. So whatever the child or grandchild is of the Docker, not the process we launched, and it restricts us to perform the actions in a certain way. So using these 6 building blocks, we can have a bigger chunks in a smart, manageable components, and these all projects have grown into separate projects. So basically, if we see Kubernetes that launches pod, which can have multiple containers and volumes associated within a single process. So Podman can also do that. Podman is daemonless. It's based on the fork execute model. It's completely open source, and it's very Linux native. Like, it's very deeply integrated into it, and it's integrated with the systemd. So we can have things managed with the systemd, not running a separate virtual machines and having all the resource exhausted. It's highly secure because it is implemented with security in mind. Like in Docker, we need to have root access and root privileged account for creating containers and running containers. Here we have rootless containers, and any users which can have access to the cell can be able to create the image and can be able to run the containers. It basically came from the libpod library, which is a container lifecycle management library, and this library was also included in the Podman repo. It provides API for managing containers, pods, container images, and volumes which are mounted onto those container. And Podman is designed to interact and search across the registry. It can, we can configure which registry it should be searching. Not it is limited to one registry. We can have multiple registries configured. It can run, build, and share this and deploy application using OCI complaint containers and its containers images. So for learning Podman, it's not like we don't have to learn a brand new CLI. If we know Docker, if we have worked previously with Docker, we are fine to go. You can see, it's if we do a alias like Docker equal to Podman, in 99% chances are there it will work. So that CLI is completely identical to Docker, which we are very familiar with. So Podman can interact with image repositories, images, containers, and pods. It relies on the OCI compliant runtime like runc, which we have discussed, crun, or whatever it's according to that specs, and it's deeply interfaces with the operating system for creating those containers. It supports OCI compatible image formats and Docker image, so it is not restricted to one. So it provides full management of images like pulling, pushing, or creating the image, container lifecycle, and container networking. Also, this can run with or without root privilege. So we don't have a special account for running this rootless containers. It has Docker compatible CLI, and there are no daemons for improved security. So it is having a lower resource utilization. So I would like to also introduce a Buildah, which has a close relationship with Podman. So Buildah is basically facilitates building OCI compatible images. So the goal is to provide lower level core utils interface to the OCI compatible images. So it provides better security, and because it's a multi-user in Linux, we can have a different shell and we can create our image. We can think Buildah, it's like a, that emulates like a run command in a Docker file, which is creating the images, and its containers are very short-lived. So it is only created just for adding the contents into the image and exit. While in case of Podman, it's a long-time containers, and that are lived for having our applications running. Like similarities with Podman, it shares like it is having both are CLI based, both are daemonless and based on the simple fork execute model, and both are OCI compatible images, work with OCI images and containers. This is the difference I have mentioned earlier. It's basically specialized in building only the image. So Buildah can be easily integrated in our scripting for automation also. So it provides that facilities. While Podman specialization is in the commands and function to maintain and modify all the OCI images, it's like what a container engine should be doing. Why Podman? Podman is, as I mentioned again and again, it's fundamentally designed with security in mind. So it leverages all the SE Linux features. So if we are using a rootless container, then we are having a small attack surface because it's just a runtime engine. So there are no daemons are running. It's no client servers are going on. So rootless support is built natively in it and integrated with systemd so that those containers services can run those containers. We don't have a overhead of the VM. Being rooted, like in case of Docker, means it's a major security issue for that. Here chances are very less for that. Initially, when the container images were running as root, system assume most of the things are running as root. So earlier, we have seen examples like the proprietary software where giving in their environment for running their environment, it's listed like you should be running as a root, then only we can provide support. But here, if it is the case, we can overcome that. Rootless containers are created, run, and managed without having admin rights. So any normal user can be able to run those containers. So beside this security benefit, the major other benefit we are having, it's like a high performance computing. So because users are using the namespace for multiple containers, so without interfering with each other, so they can run multiple applications in different namespaces. From security perspective, fewer privileges are always better. If in case of container engine, runtime or orchestrator is compromised, attacker won't be able to get root privilege on the host if it is in case of rootless containers. So it allows isolation inside the nested containers also. So earlier we have seen like Docker runs everything as the grandchild or child process are the of Docker, but Podman creates the child process, not as we have the case with the Docker. So the maximum permission a user can, a normal user which is having a selection is having the maximum permission that user is having, not beyond that, that is permissible. So compared to Docker, if we give Docker socket which is running as root, it's like a sudo without a password. We can mount the volume and can blow away the container, and all the logging can also be get eliminated, and we will not be able to track down what has happened to the system. When we run the Podman as a rootless storage, it is created in our home directory, not in case of Docker like we have in var lib storage. It will be in our local home directory, and we can simply pull the image and run the container, so no root is needed for that. As we have seen from the starting, it uses the namespace in Linux, and the call we have Buildah unshare. So we basically put the user namespace without being into that container. Like here in this figure, we can see that it is deeply integrated with systemd. We can have a container, we can have a process running inside the container, but that cannot be possible in case of Docker, because Docker talks to the daemon on the another socket. So in Linux, whenever we log in, so there is always a login UID So we are always tracked whether whatever type of process we execute, whether we do a pseudo process or a non-pseudo process. So we cannot change this login UID once it is set. So in how Podman uses that login ID, so whatever we are doing using Podman when we are running a rootless container, then that Podman is using our login ID to track whatever we are doing with that. But in case of Docker, it is giving the that ID of the Docker, not the user who is doing all those things. So suppose if we have done something nasty to the system, Docker says Docker has done something nasty. And if it is Podman, it says like Akshat has done something nasty. So we will always be tracked whatever happens. So access to the Docker socket, like we have seen, it's more powerful and more dangerous than a sudo, because there we don't need any password to any problems which has happened because of that. Because in Podman, we know already who the user is and what he is doing. All that is tracked with the login UID. So on Debian, we can install Podman. It's a package pretty much available there. And these are the links where this libpod is there, and Debian is maintaining that Podman package. So these are my references. Yeah, that's all.
Thank you. Thank you, Akshat, for this nice and very informative talk. Do you have any questions? Are there any questions?
Thank you. Does Podman support the same storage backends as Docker does?
What?
The same storage backends?
Yes.
VM and
Yes,
B3FS and whatever.
Yes.
Thank you.
Any other questions? I have a question. I've heard that Docker has started to support rootless containers as well. I don't know much about them. I wonder if you know something about them and how does it compare with Podman rootless containers?
Docker rootless containers you are talking?
I think they support something like rootless containers recently, I think.
Okay, that I am not aware of, but it's nice if they are supporting. But
okay.
The main problem is that with the Docker daemon, if we are getting that access, then it's a big security issue.
Okay, thank you, Akshat, again for this very nice talk. Let's give a round of applause. Let's.
Thank you.